Hey, what's up, guys? So I got kind of a fun IoT project here to share with you. You know, from all my other videos, I'm always trying to integrate technology into my other hobbies. And one thing I'm into is astronomy. So, you know, there's nothing more relaxing than cracking a beer, going outside with the telescope and observing the universe. So, of course, you need clear skies for this. So I developed this little box here that sits on top of my telescope, and all I have to do is just glance over at it, and if the flag is up, we know there's clear skies. So let's take a closer look. Well, it's a little rainy out right now, so of course we don't have clear skies, but I put it into a test mode and you'll see what happens. There you go, when we have clear skies. So all I have to do is glance over and we see the flag up, so we know we have clear skies. And if we don't, it goes back down. So let's take a look inside the box and see what we got going on. All right, and looking inside the box, all we have is a simple TrigBoard, which has the low-cost ESP8266 Wi-Fi module, a battery, and a servo, and that's all there is to it. I was actually inspired by the guy with the Swiss accent. He just did a video very similar to this to check the weather conditions, and gave me the idea to build this, a very simple, easy project based on the TrigBoard. So that's all there is to it. And the way this works, let me unplug that real quick. The way this works is that the TrigBoard, with its ultra low power circuitry, allows this system to run off of a battery, and it sleeps for 3 hours. It actually wakes up once an hour, but it increments some non-volatile memory and keeps track of how many times it woke up. So right now I have it set to wake up every 3 hours and go ahead and connect to openweather.org, and it checks the weather conditions currently for the zip code that you had programmed in. We'll talk about that too. And if the skies are clear, if it sees clear, it will raise the flag. Otherwise, it will keep the flag down and go back to sleep for another 3 hours. And all of this stuff is configurable. So there's actually a lot of interesting concepts we're going to go over in this video. We'll talk about connecting to openweather.org over the HTTPS connection. We'll talk about how to pull down and parse data using the Arduino Json library. We'll also talk a little bit about the Wi-Fi manager and how you can load in any unique credential you might want. And in this case, we're loading in the zip code for the location you want and your API key from openweathermap.org. So that is what we're going to talk about in this video. So lots of good stuff. Let's go ahead and get started. I just want to talk about the setup real quick here. So I am using the TrigBoard for this. Here's the wiki page for it and everything you'd want to know about it and how to use it. It is a host board for the ESP8266, and it has all that low power circuitry that works great for this kind of project, especially because it has that timer so that we can sleep at less than 1 microamp, wake up once an hour, and the battery will last for a very long time. Of course, I am biased to using the TrigBoard because it is my own design, and of course I do have it available for sale if you're interested, at least at the time of making this video. So you can use the TrigBoard, or you can use any board you want that has an ESP8266 or even the ESP32. So that's pretty much all there is to the hardware setup. And then running over here to openweathermap.org, this is where we're actually getting our current weather status from, and this is what gives us that keyword clear that we're using to determine if we have clear skies or not. So you will need to set up an account with them and get an API key. So I already have that, and I'm just going to share my API key with you here. Of course, I will delete it after making this video, but don't really feel like blurring that out every time you see it. So anyway, you will get a key. You need to use that in your calls to openweathermap.org, and we'll talk a little bit more about that. But what's nice about this is we go over to the API documentation, and they've got examples for anything you'd really want to get from them. And for us, again, all we need is current status. So I'm going to go to API doc, and we're going to make a call based on a zip code. And they give you an example here of how you would set up your URL, and you can see that the zip code is appended to the end of the URL. but you also need to add in your API key. And I do have an example of that in the Arduino code here, which will be available for download. Just see the description below. So right here is what you would need to set up your URL. You see zip equals, that's where you put your zip code, and then APPID right there, that's your API key, and you put that right there, make that call, and then what you get back is this, which is a big JSON string. Okay, so this is a call using zip code for downtown Cleveland 44113, and you get this. So usually what I do first is copy that out and then go to some web page or whatever that does JSON formatting for you so you can see what everything looks like. So I'm going to paste that in right here, process that, and then there you can see all of the JSON data parsed out or formatted. So what we're after is the main right here. And this right here will be clear when we have clear skies. So we'll see clear right there. And if you go back here, this may take me a second to find, but there's somewhere in here where they actually show you what all of those keywords are. All right, so I found it. All you have to do is go to API here, scroll down a bit, and you will see right in here, list of condition codes. Click that, and then right up here, weather condition codes. And then when you go here, this shows you all of the icons that you can use for whatever app you're creating. But what's interesting is it actually just tells you what text to expect based on the weather conditions. So here's the same JSON string we were just looking at. And we're looking right here at main. So you'll see rain, you'll see thunderstorms, you'll see, and if we just scroll down here, you'll see thunderstorm, drizzle, rain, snow, and then clear. Okay, so clear is what we're using. That's what we have in the code. And if I go here down to get weather, we'll go over this in a little bit. But see, if we see clear, that's when we turn the flag up. So I think that's just about all I wanted to show you there, is how to get set up with openweathermap.org. Now we can discuss the code. But before we do that, let me actually just give you a demo. So I've got the code here. I just flashed it. Let me show you those settings real quick. I always use the Adafruit Feather Huza board in my board settings, and then these are the default settings. And right here is a newer thing that they have in there, where you can erase all flash contents, not just the sketch. So I just did that, just loaded this in. So that means that it wiped out all of the Wi-Fi settings and the zip code and API key I had in there. So right now I'm going to wake the board up, and when we do this, it's going to launch itself into an AP mode that we can connect to it and load in those settings. So what I'm going to do next is click on my Wi-Fi settings here on my computer, connect to Clear Sky. I believe that's what I used. If we go to provisioning here, again, we'll go through this code in a second, but yeah, I call it Clear Sky. So we're going to connect to Clear Sky, and I'll be right back. Okay, so we connected. The captive portal window opened up for us automatically. I'm going to click Configure Wi-Fi, and here's where you would click on the SSID you want it to connect to, put that password in, the zip code, and API key. So I'm going to go ahead and do that now and save. Okay, just hit saved on that, and now it's going through and saving those settings. It's going to connect to the AP here, and will automatically connect and then go back to sleep. That's the way the code works. And there you go. I've also just quickly opened up the serial monitor so you can see that I actually do print out the full JSON response and then show what it parsed out, and it was rain. So then it actually set it to the 0 position or the down position for the flag. And then that's all there is to it. So now it's just going to sleep for 3 hours, wake up, and check the weather. And if it's clear, it'll raise the flag. Otherwise, keep it down. So that's all there is to how the code works. Now we could get into the details of it, and we'll go through it. All right, now we could jump into the code. But you know what? A lot of this code was just leveraged over from the base firmware that comes with the TrigBoard. So if we go here to the wiki base firmware, just to show you that the latest release is at 10.818. And this is the version of everything I'm using, all of the libraries and the Arduino ESP core and stuff. So that's pretty much everything that's on this thing. So I think I'm just going to focus on the new stuff for now, which of course we have a servo in there now. But if we kind of scroll down a little bit here, right to setup in check trigger, that's the first thing we do, and that's the standard thing with the TrigBoard. And by the way, if you're new to the whole TrigBoard project, you might want to check out some of the videos I've got up here in the wiki. Like this one's pretty good, that actually goes through that code line by line and explains exactly how everything works. So again, in this video, maybe just focus on the new stuff. But anyway, so jumping right into it though, in setup, the first thing it does is go over to check trigger. It has to figure out what woke it up, if it was an external wake, like from a door sensor, or if it was the built-in 1 hour timer. It figures that out right here, the first thing it does when it wakes up. Which, by the way, again, if you're new to the TrigBoard idea, the board is actually killing power to the ESP8266, and that's how it's able to get that sub 1 microamp sleep current. So when you wake up, we're actually doing a full power on of the ESP8266, okay? So anyway, because I don't want to actually check the weather every hour, I need to keep track of where I was. And again, since you're losing power, you can't store that in RAM. You have to write where you were at in non-volatile memory. That's why we're using the EEPROM library, and we're going to keep it in 20 bytes. And this is something called wear leveling, because we only have so many cycles that we can write to a certain memory location. So what I'm going to do is actually increment where I write in the EEPROM, okay? And I'm using 20 bytes for that, and that's what all of this code does right here. And it's actually pretty straightforward. If you kind of work through it, you'll see how it works. So you see right here, it's storing it in 20 bytes. So the first thing it does, it has no idea which byte it was stored in. So the first thing it has to do is do a quick for loop and check all of the memory locations. Now, reading the memory isn't going to hurt anything, okay? So that's why we can do that. So we read all 20 bytes out. If any of them are greater than 0, then we know that that's where we were storing it, okay? So we keep track of that. We have the wait count, and we have the wear leveling index, which is stored at I, and then we break out of this. So it's like, okay, we found where we were keeping it. So at hour 1, we wake up, 1 hour has elapsed, we wake up, we saw a 1, an hour has elapsed, now we'll see a 2 at the wait count. Okay, does that make sense? Hopefully. Now, if you did a fresh download of the code, there's not going to be anything in there. So in that case, you would hit 19 here. So we just say wait count is equal to 1, and that's what we're going to use. And then who cares about the wear leveling index at this point? It's going to be, it's actually just going to be at 0. So it doesn't matter at all. So just keep that in mind. So anyway, okay, so we found where it was in memory. Now we're kind of going through it. It's been running for a while. We found where it's at. The first thing we do is burn it out of memory. So we write to that same location where it was back to 0, because we're going to increment it and write it to the next location. And that's what this does, and checks, of course, that you don't roll over on it. And then some debug stuff in there. And if you are less than your sleep hours, and in this case 3, then we're going to increment the wake count and write it in at the new wear leveling index, since we incremented that, to the new wake count. And then we get out of it. We don't want to do anything at this point. So by just doing this while one loop and wiggling the done pin, it's going to put it back to sleep and kill power at this point. Otherwise, we are greater than our 3 hours, we're at our 3 hour wake point, so we're going to stay awake. But we still need to burn it back in, so we're going to reset the wake count and write that back in. We're done with the EEPROM, and now we go on through the rest of our code. Okay, so that is read file here. So there's a couple of new things in read file. If we go over to the credentials tab right here, this is how we set up what variables we want to store. So I did talk about this in other videos, but just to show you that stuff here. So we're checking for the zip code API key, and if there's nothing there, just wipe out our memory. Maybe there's some old stuff in there. The new thing with the board here, the boards manager, is that you can actually configure this to erase the flash contents, which is nice. So, which is right here, all flash content. So if you wanted to wipe out the flash memory, you can just do it when you upload it. And I like that, that's cool. So anyway, so yeah, now we have those two things, zip code and API key. And then back to the setup here, Wi-Fi connection. Of course, it's gonna need to connect to Wi-Fi. So right in here, we're going to add those new parameters, the zip code, the API key, and you can follow this kind of format if you're going to use this sort of thing in some other application. So we're going to use those two. Those are our two new parameters. And then it's going to try to connect, okay? And if it can connect, good, it gets out of this. But if it can't, it will launch this AP at clear sky, and that, just like you saw, we can put in our SSID password and those other parameters. We're connected, we're good. It takes them out of that, if we needed to, it'll take them out of that captive portal and store them back in where we can use them in the code. And then, of course, if it needs to save it, it'll save it. Again, you'll notice a couple things in here that are new for the zip code API key. Otherwise, we're done, okay? Now we can go and get weather. We're connected to the Wi-Fi. Go to get weather right here. And right in here is how we connect to it. So we're going to connect. It is well, actually I have it kind of different there. We're going to actually connect to it HTTPS, and we're going to connect to it over to port 443. I was kind of surprised I have it set up like that, but anyway, that's the way I've got it in here. So anyway, it's almost like I haven't seen this in a while, but okay, anyway, going through it though. So this is actually the same exact setup I had for Pushbullet and Slack and connecting to some other things like Adafruit io.adafruit. I've connected to the YouTube API and so on. So it all kind of follows this same sort of format. But in this case, we're actually going to pass the zip code and API key in the URL. So right here, we're going to build that out. So there's your base URL right there. And then zip equals to, so now we can do a url.concat, and that will add zip code to that string. Then we have to add in the .us with the app ID, and then the API key to that. Now we have the full URL, and then we do the get on it. Okay, same format as Pushbullet and the other things I've done in the past. And then what we do here is connect to it. And while we're connected, we're looking for the new line, because we'll get that after we go through and we get the headers. We're going to get a couple new lines. This took a little bit of messing around with to get right. And then as soon as we see the carriage return, we've got the headers. We're good, got the headers. We set that Boolean to true. And then we get out of that. And if we get those headers right here, we're going to load in all of the data until we see a carriage return. We're going to store that all in line, and then we set up the JSON object here, store it all in root. So that was this whole thing here. So we're going to store that whole thing as a JSON object, store it all in. Where am I going? Back here. So now we have root, and then just want to show you this. So this is the key here to what I was sort of getting at with this project, is how to parse JSON data. So we're going to store this as weather condition, which we declared as a global variable somewhere right over here as a string. Okay, so I keep jumping all over the place. So right here in get weather, you see root weather 0 main, and then format that as a string. And then going here though, just to show you that, I'm going to collapse some of these things. So you see we have, let's close all of them. There we go. Okay, cool. So we have weather. That's the first one we want. So you see weather. And then 0 in brackets, almost like it's an array, which it is, see in brackets. The first one, because it's this, there's only one item in that array. And then main You see how it's kind of falling together here? 0, main, and then that is where we'll see, let's go back here. And then that's where we would get rain back out of it, which I showed you in the serial monitor. So now that's how we get it out. And this works for parsing any JSON object, but like you saw in the video with the guy with the Swiss accent, sometimes these arrays can be huge and will crash the ESP8266. So you got to be careful. Like I did a display project for a Bitcoin. It was like a Bitcoin price ticker, and I was getting back a huge array. So I did have to do something similar to what Andreas did in his video, where you have to kind of chop it up a little bit before you can parse anything out. So anyway, we get that back. We pull out the main there, and then as easy as that, we check if it's equal to clear, and if it is, write it the servo to 90, which by the way is on pin 5 of the TrigBoard. Going back here to the top, that would be right here, GPIO 5, and I'm running the servo off of the board's 3.3 volts, which also kills power. So that would be on the other side of the board. There's a little 3.3 volt tab, and then pad, and then the ground pad up here, and then the data pin of the signal pin of the servo on GPIO 5 right there. All right, and then that's all there is to it. Give it a little bit of a delay to let the servo arm move over, and then it gets out of that, jumps back, got the weather, goes into the while one basic loop here, the void loop, and kills power, and wakes up once an hour, and then once we see it hit over to the wear leveling stuff, once it detects it went over the threshold of 3 hours, boom, we wake up, grab the weather, do the same thing, go back to sleep. And that's all there is to this code. So hopefully you found that somewhat interesting. It's kind of a fun, quick little project. Thanks for watching.